we have talked about flipping functions. Vertically up, down, horizontally left, right. We have talked about stretching functions. Vertically, like so, horizontally, like so. And we have talked about flipping functions over the axes. So vertical like so, and horizontal like so. So just to sum up, here is what I would call the transformation equation. All the stretches there represented by the different letters, besides F and X, of course. A vertical stretch is represented by which letter in the transformation equation? A. Okay. And remember, that's a vertical stretch by the factor of A. We take out the negative when we talk about stretching. Negative means a flip, which we'll address a little bit later. And what this also means, every y value in the original function gets multiplied by whatever the value of A is without the negative. Horizontal stretch is represented by the letter B. And this is a horizontal stretch by a factor of 1 over the positive of B, if it happens to have a negative. And how does it affect the coordinates in the original function? Every x value gets multiplied why it keeps doing that. Okay, stop this. And let's try this. Let's ignore that it gets. Every x value gets multiplied by 1 over the x value of b. Okay. A reflection over the x-axis is represented by which letter? Where would I find a reflection, a vertical reflection, or vertical flip? Yeah, here at A again. Right? So it's going to be at A again, and it's the sign of A. So if A is greater than 0, make sure I get this right. Or sorry, A is less than 0. A is negative. Okay. Every y value in the original functions changes sign. Okay. So notice that A is affecting the y values, B are affecting the x values. So a reflection over the x-axis is also represented by B if it has a negative prime. So if B is less than 0, every x value change of sign. Oh my God. Stop it. I just want to get this out of here. Would you go away? Oh. Okay, I give up. I'm just going to leave it. Let's go on to the course. Shift. Horizontal shift is represented by what letter? Sorry? H. Okay. And if H is greater than 0, we move H right. Or X values plus H. If H is less than 0, we move H left, and we do X values minus H. And finally, vertical shifts are represented obviously by K. So if K is greater than 0, we move K up, or the Y values plus K. If K is less than 0, we move K down, and it's the X values minus whatever the value of K is. Actually, I should say minus the absolute value of K, and the same here with absolute value of X. Because like if the value of H is -5, that means I'm going to go X minus 5, not X minus -5. That's why I put the absolute value. Okay. So if you were given an original function and a new transformation function where it involved everything, okay, the mapping notation would look like this. Well, if there was a flip, you'd need a negative, a horizontal flip. If there was a stretch, you would multiply the X value by 1 over B. And if there was a horizontal shift, you'd have to add H. And here, if there was a vertical flip, it would be negative. Stretch, there would be absolute value of A, because we don't include the negative. X, and if there's a vertical shift, it's plus or minus K. Actually, I should put plus or minus H plus or minus K. So if you're doing all 6 transformations to something, you're using mapping notation, there is a fair amount to keep track of. And remember, the F in a transformation equation stands for the type of function it is. Okay? We did some questions where we knew the type of function because it was x squared or because it was absolute value of x. Most of the functions we're dealing with, though, we don't know what specific type of function it is, so we just refer to it as f. And the b, we haven't talked about this yet, but inside the function, the b must be factored out. And I'll show you an example in a second. about when you're going to have to do a factoring. And it's actually GCF factoring. It's pretty straightforward. So I didn't put this on anywhere, but students seem to like when I do this. I like to use it as sort of a reference. Okay. So I don't know if you want to copy this down or take a photo of it. Done. Okay. So everything outside the function is vertical, which means it affects y. So this is negative, it's a flip, vertical. If there's a number here, it's a stretch, vertical. If there's a number at the end, it's a shift, vertical. Everything inside is horizontal, which affects x. So if there's a negative here, it's a flip, horizontal. If there's a number in front of the x in parentheses, stretch, horizontal. If there's a number being added or subtracted to the x, shift, horizontal. So everything inside is horizontal, everything on the outside is vertical. Okay? Just keep that in mind. Because I want to look at a few examples. So we'll start here. What we are asked to do is we are given a transformed equation of a function and asked to describe all the transformations that took place. Something to keep in mind. Whenever, okay, you are describing transformations or using mapping notation or graphing, always describe the vertical stretches and reflections first. The translations or the shifts are always put at the end. It doesn't matter whether you do reflection or stretch first, but they always have to be done before the shift. Okay. So knowing that, describe, and when you see the word describe, that means words. Everything that's taking place in this function. Somebody tell me something. Yana? You're missing a word. Right. Vertical stretch, factor of 3. Stretch. You never shift by a factor. You stretch by a factor. That's it. What's up? Are you giving me another one? Good. Horizontal stretch by a factor of, remember everything inside acts a little funky. Flip. Horizontal stretch, factor of 2. You can't say horizontal stretch by 2. That is insufficient. You need the phrase factor of. Okay, so we've dealt with this and this. So pretty straightforward. What's left? Yeah. Shift 5 down, or vertical shift 5 down. And horizontal shift 4 to the right. Yeah. This next one, B. Look at the inside of the function f and compare it with the inside of this function. Here, I'll erase these things, get them out of the way. So compare this with this. Play a little Sesame Street. One of these things does not look like the other. What's the difference? Well, how do they look different? Gilly? Brackets, what about them? No? You're waving off? Melissa?
Oh,
Stretching? Want to answer?
it was like brackets around the X minus.
Right. Whereas here, there's not. Okay? This is not properly factored. You cannot say that B is 2 and H is 4. Because if there's a number here, there's a shift going on, I need parentheses inside. So we have to factor this, and the way we factor is GCF. So what can I take out of these? 2, and I'm left with X minus 2. Notice the horizontal stretch is still the same. It's the horizontal shift that if you don't factor it, you'll miss. Okay? So something like this, you don't have to write this down. Okay? Do I have to worry about factoring there? No. I mean, how can you factor one term? Right? Doesn't quite make sense. Do I have to worry about factoring here? No, it's already factored. How about that one? That I have to factor. Okay, that's actually a really weird one. I shouldn't have given that as an example. I should have given it. I'll just do plus 12. Yeah. Yeah, that has to be factored. Don't worry, factor that. Okay, so now that we've got it factored, let's describe everything. Sonia?
Vertical stretch by factor of 2.
Vertical stretch. Factor of 2. Yep. I'm not. Yep.
So that would be talk about.
Sorry, I can't.
Talk about how it flips or not.
Oh, yeah, and you have to do those two. Okay, yeah, so the vertical stretch by a factor of 2 just talks about the 2. I haven't talked about the negative yet. So I've got to do that. Either you can do the horizontal stretch next if you want, and then the flip, or you can do the flip. It doesn't matter. So let's do it. Let's do the flip. Vertical flip over, because you should write it like this, over which one? X. Okay, so we've dealt with the negative and the 2. Remember, this is the form we're looking at, not this form. Simon?
Stretch by factor.
Horizontal stretch. Factor of 1/2, because you got to flip it. So that takes care of that. Alyssa?
Vertical shift 5 up.
Vertical shift 5 up. That takes care of that.
Horizontal shift 2 right.
Horizontal shift
2.
2. Yeah, that's the one you got to be careful of when it's not in factored form. Because we're not looking at this one, we got to look at that one. Okay? So that's one type of question that you may be asked. Another type of question that you may be asked is give the formula for the mapping notation. Do I have to worry about factoring? No, it's not. Like there's a horizontal shift going on, but there's an inner set of parentheses, so it's factored. Okay? So I need to come up with a formula. Well, what's the 3 doing? I got to look at all the numbers. What's the 3 doing? Horizontal stretch by a factor of a third, right? Okay, so does that affect the X or Y? X, horizontal affects X. So I need a 1/3 times the X, and I've dealt with that. What about this? Horizontal shift left 2. What's that? X, you said? What? Well, you got, I can't hear what you guys are saying. -2. X -2 or Y -2? Right. Nothing's in front, nothing's at the end, so nothing is happening to the Y's. The numbers were only affecting the X's. Okay? Here we're going to do the mapping notation again. We'll finish off with these ones for now. Remember, always just do a quick check, especially if it's a complicated transform function, that it's factored properly, the inside. Well, there's no number in front of the X, so I don't have to worry about factoring there. Okay? So the order really doesn't matter. I mean, we can still do the stretches first, but it's not really going to impact the mapping notation. So what's this going to do? So what, X or Y, and what's it going to do to it?
Y.
Y times 3, or 3Y. What's this going to do? It's going to shift 1 to the right, which means X plus 1. Because if it's going to the right, that's moving in the positive direction. Okay, that takes care of that. And finally,
So Y.
yeah, we're going to add 5 to the what already is there, 3Y. Next one. All right.
1,103. That's we have to.
Yeah. Got in the right form. Okay, there should be another set of parentheses in there. It should be GCF. So 3 times X plus 3. So keep that in mind. Okay, the 2/3. What's happening to the 2? What are we doing with the 2/3? Sorry? I can't hear you.
2/3 times.
Thank you. Oops, I should turn it up a little bit. Yes, it's being multiplied by every y because it's a vertical stretch. The 3, no, let's do the stretches first. 1/3 x. Because this is a horizontal stretch, but the stretch factor is actually the flip, 1/3. Okay, almost done. From the x's or y's? We're taking away 3 from the x's, and we're taking away 4 from the y's. Good. Okay. So that's showing how you can describe in words and use mapping notation to describe transformations, multiple transformations. Next thing we're going to do is we're going to do graphs and then see what transformed graphs look like that have multiple transformations. And then we got to work backwards. When you're given 2 graphs, an original and the transformed, you need to figure out what the equation is. Okay? But we'll do that next class.